Hello, in this video we're going to explore the Mavlink 2 communication between ESP32 and the mission planner. When ESP32 connected to separate computer and the mission planner installed on another computer, and they are communicating via Wi-Fi. The main idea here is coming from the drone design. Sometimes in drone you have a mission computer, but you're also using a companion computer. So in this case, ESP32 can be used as a companion computer which can communicate with the ground station, in this case mission planner installed on PC. Just to be clear on the hardware setup, we have a PC1, the PC that we are currently presenting from, with mission planner installed and running. We have the Wi-Fi communication to ESP32, and in order to compile and flash the code on the ESP32, it's connected via USB to the second computer, which we will see in this video in the next stages. Okay, so regarding our resources, we are in the Sims IoT devices repositories inside the Mavlink repository, where now we are talking about video number 7 with those 7 files. And here is a brief explanation regarding every file, what its functionality and so on. On this computer we will be using the Sniffer. So before we are going to the mission planner, we just want to see which kind of messages we are receiving. So we are not starting with mission planner, where is waiting for the UDP messages. So we will run it. And now it's listening on the port. And I will run the Python code on my second computer here. And it's sending a heartbeat message and the parameter message. Because he didn't receive any reply, he stopped sending. Now I will send the same from my ESP32. Let's wait for it to compile. Okay, it's finished the compilation and connecting to the Wi-Fi. And now it's sending the messages from the ESP32. In the same way, you can see that the messages are exactly the same. In the moment we will see it from the other computer. And because we didn't send any reply, the transmission has stopped. Okay. So we proved our point that the messages sent from the PC running Python code, which you have here, actually this one, and we are using this Sniffer, have the same build as messages which is sent from the ESP32. Now let's go to the mission planner, and we will run the ESP32 code. Now the ESP is compiling. It's finishing its compilation, so I will try to connect. The mission planner is waiting for the Mavlink message. Wi-Fi is connected. Now we are sending the heartbeat message. Let's see if this message will be received. Okay, now the parameters. And now we have full connection, which we received from the ESP32, and the connection is perfect. Now let's go to the other computer and see how exactly the same process is looking for the other side and how the code is actually running. Okay, now we are on our second computer, and in our repositories and Mavling, we are going to use those two files from the 7th tutorial, where on our first computer we use the sniffer to receive the messages. Here we will use the Python file for reference and the ESP file for the real communication. So let's run the sniffer on our first computer. We're basically repeating the same process that we did, and run the Python file to see how it works, just for reference. After it, we will continue to the ESP file. You see here, we are sending a heartbeat message, and we didn't receive any reply, and the transmission has stopped. Let's see how our ESP code will work. We will run the ESP code. And now it's compiling. Okay, the ESP code has finished the compilation. He is connected to Wi-Fi, got the IP, and you see we send the heartbeat message, we send the param data, and didn't receive any information, so the transmission has stopped. A quick reminder, before we communicated to our computer with the mission planner to our first computer, we ran ipconfig and defined the IP and the port, the IP from the ipconfig, and the port was predefined in order to know to which IP to connect. Okay, so we'll stop the execution. Now I will close the sniffer on our computer and open the mission planner. Now let's see how the Python file will run on the mission planner. We're starting the connection on the mission planner and now running the file. The first, I will just open it to be it more clear. We sending the heartbeat messages and the parameters, and now the connection was established. You can see all the messages that we have sent, and now we have a proper connection to the mission planner. So let's repeat the same process with the ESP32. We'll clear this one and disconnect on our mission planner. Let's compile the file. Okay, the file is finished its compilation, so we'll try to connect on the mission planner. Mission planner is waiting for the Mavling communication. Wi-Fi and IP are established. Okay, it's still looking for the heartbeat. Now the heartbeat has received. It's looking for parameters, and parameters were received. And we established a full communication with the ESP32 code to the mission planner installed on the first computer. Now, just to see what we are seeing on the screen, you see we have a limited number of messages where we connected to the known IP with the known port. We send the heartbeat message, and we're always sending the heartbeat message and the param message, and then receive different messages from the mission planner. And those are the messages that we have received. You see, those are different messages according to their lengths and substance. Inside the Python code, you can read the parsing of those messages just to understand what mission planners really want, but it wasn't still implemented in the ESP32 code. And this is basically it. Now, just quickly, let's go over the ESP32 code and to see how it's built. The main idea is to send continuous UDP message, which is sending heartbeat and the parameters together in order to establish the connection to the mission planner. Inside my data, we have our Wi-Fi credentials. And these are the known IP, which we checked with ipconfig command from the command line on our first computer. This is the IP of our first computer, of our internal LAN network inside the house, and the port, we're using the same predefined port. This is a heartbeat message that we are sending, and explanation of each field of this message. We covered it in the previous videos, but it's a pretty standard Mavlink 2 message. Then we have a param message which holds the value 22, param value 1, and param name param 1, exactly as in the Python code. Here you can see it in very clear form. And exactly the same data to be transmitted via ESP32 by hand is written in those fields. Okay. This is a function which is used for Wi-Fi communication, the Wi-Fi handler. This is actual Wi-Fi connection. And we are running the UDP client task. This is the only task we are running, where we define our parameters with the address of the socket and the parameters for receive information in order to receive the messages from the mission planner. First, we create a socket. Then we define the buffer size, connect to the server, and after successful connection, we're starting to send messages. We're running this process in for loop for like 20 times. When we are running the counter, calculating the CRC by hand, it was explained in the previous videos, and updating the message, because Mavlink have to receive a continuous heartbeat messages every second. Then we update the heartbeat message and sending a final calculated heartbeat message, which is changing every second. The basic change is the counting number and the CRC, because the counting is changing. So we can maintain the connection. With every message, we also send the param message with the parameters, basic parameters that we explained earlier. Then we receive the information from the mission planner and present it on the screen. Wait for 1 second and do it like 20 times. After it, we're closing the socket, and this is the program execution with the Wi-Fi connection and the execution of the UDP task. So that's basically it. We demonstrated connection from the ESP32 to the mission planner installed on the different PC via Wi-Fi, and the establishment of a proper connection between them. Thank you.